Question number 7 from March 2020 and paper is 12 number. Okay, in this question, clearly they're saying find the area of the shaded region and they have given details of this diagram on the right side. These two formula, they are universal with circular measure. You should always be aware of them. They are given to you in your formula booklet. One third formula which should be known to you should be this one. Half BC sine A. This is the area of a triangle. You should always be aware of these three formula to be successful in solving any circular measure question. So now let's come back to our question. We need to find the area of the shaded region. In circular measure, our approach should be that how can we get this area, any area, as an addition or subtraction of these three. Okay. Now pause this video and think, and then after a few seconds I will start it again. You can pause the video. Okay, so now let me redraw this diagram. If I take this triangle AOC and this sector DOC, this sector, if this is cut off from the triangle, we will be left with the area we want, and that's it. We should have the area of triangle AOC and we will subtract the area of the sector DOC, and that's the challenge. Here in these two we know only the angle, nothing else. The other information they have given is this 6 centimeter length. Let us focus on the triangle AOC first, this one. How to find the area of a triangle? This is the formula, and also they are giving that this is 90 degrees, so we can use the old age formula, half base times height, any one you like. But I would insist we use this so that we're getting used to it, and anytime in future we can use the same formula. So first we should understand the formula. This formula of area of a triangle is half BC sine A, which will come back to this only. So B and C are any two sides of the triangle, and angle A is between those two sides specifically. It cannot be any other angle. It has to be the one between B and C. So if I focus on this triangle again, this is my drawing. I know this angle is 0.8. Yeah. And this side is known to us because we know that the radius of the bigger sector is 6. This is another radius of the bigger sector. That means this is also 6 centimeters. So we know this side 6 centimeters. If somehow we find this side, so we can use the area of a triangle. And we can find this side by what? Cos theta, cos 0.8. Let me do it at the corner. Cos 0.8 is equal to OC divided by 6. 6, that is the hypotenuse, right? So that means OC is 6 cos 0.8. What is it? Let's not evaluate. Try not to evaluate because we have to round off the answers of these, and that will affect our answer, final answer. So let's leave it. 6 cos 0.8 is the length of OC. And now we will find the area of the triangle, which will be half. For us, B is 6 centimeter. C we just found out, 6 cos 0.8. And sine of angle A, which is 0.8, sine 0.8. Let's put this in calculator and we'll find our area of the triangle. I got 8.996 centimeters square. And let's focus on the sector DOC. The area of a sector is half r squared theta, and theta has to be in radians, and our theta is in radians for the sector, so that's fine. So it will be half r. What is radius of this OC? We just found OC. 6 cos 0.8. Let's not evaluate, just write it. Cos 0.8. This is r, and r square we have to write and multiply by theta. And theta is 0.8 again. Put this in a calculator and I got 6.989. And now we know both the area, just subtract the area of shaded part equal to 8.996 minus 6.989, which will be about 2.07, or you can write 2.1 centimeter square. That's the final answer. I have kept the two formula back, and I will write the area of the triangle again, half BC sine A. Okay, so in this case they are asking the perimeter of the shaded region, not the area. This time it's perimeter. So the perimeter of this will be this side plus this side, this arc. Okay, so now to find both, rather all three of them, we need to find this angle, isn't it? If we find this angle, we have a right angle triangle. We can find its adjacent side, we can find it opposite side, and with this, with the help of the sector, we can find arc length also, because we have a formula for arc length. Yeah, so let's do them one by one. So to find this angle, if I know this angle, I will just subtract it from pi radians. And yes, I can find this angle by this first formula again. So if I look at this big sector, major sector, 15 centimeter is the length of the arc, right? And radius is 6. So we can find the angle it is subtending on the center. Yeah. So we know that arc is r theta. Arc is 15. Radius is 6. So theta will be found out now. Let's divide both sides by 6. So 2.5 equal to theta. So this angle is 2.5. So the remaining angle will be pi minus, this is pi minus 2.5 will be the angle we want. Okay, and I will not evaluate it. Let's keep pi minus 2.5 till the end. Why? Again, the reason is that we'll have to round off numbers which may give us little off answer. So let's not change it to any number, just keep it like this. All right, let me redraw the triangle again. Whenever there's some confusion in the main drawing, you can draw it separate. So this is X, this is O, and this is B. My purpose is to find this length first, OX. Okay, so we know this will be 6 centimeter. Why? Because the radius here is 6. So radius this side will also be 6. So 6 centimeter. Just like the previous question, 6 cos theta we can use. Cos, and the angle is pi minus 2.5. Pi minus 2.5 equal to OX over 6. So OX becomes 6 cos pi minus 2.5. Similarly, if I use BX, it will be by the same process. In place of cos, it will be sine, because that one is opposite. So it will be 6 sine pi minus 2.5. Okay, so now if I want to find XC in the main drawing, look here, XC. XC will be OC, which is the radius, minus OX. And OC is known to us, 6 centimeters is the radius, full OC. Minus, we will subtract OX. We just got OX, 6 cos pi minus 2.5. Got it. So we'll evaluate this later. Let's write the second, which is bx. Okay, bx is already known to us. This is bx. No issues. So now the arc BC is required for fulfilling the perimeter. BC. Arc BC will be again by this formula, arc length is r theta. Radius of this sector BOC is 6. Angle is pi minus 2.5 that it is subtending on the center, and that's BC. So perimeter of this shape will be XC plus BX plus arc BC. Just add these three and all three are ready with us now. Let me put it one by one. So P equal to XC is 6 minus 6 cos pi minus 2.5. Next, Bx is plus 6 sine pi minus 2.5, and arc BC we just got 6 pi minus 2.5. Just put this whole thing very carefully in your calculator, and the answer you will get will be 8.63 centimeter. That's the final answer. And here they are asking us to show that exact length of BC, this length in this sector whose radius is 2r, r plus r, 2r is this one. So we know the angle here 1 over 6 pi radians, this one. Okay, we know this side is r and we know this side is 2r because it's the radius of the same sector. So they have already given 2r here. So we know two sides and the angle between them. So we have to find the opposite side BC. And for that we need cosine rule. Whenever we have two sides and the angle, included angle between them, we use cosine rule to find third side. Let me go to the formula sheet and see if cosine rule is given there. Trigonometry. I can't see it. That means you have to memorize cosine rule. So cosine rule is a square equal to b square plus c square minus 2bc cos a. Side A is opposite to angle A. This is very important, and that's what we have to use here. So A square, BC is A for us. Let's assume that as A, okay? And B and C will be the other two sides. OC and OB will be B and C. So we know they are R and 2R respectively. Minus 2 times BC, R, 2R, and the angle opposite to A is 1 over 6 pi. Let me write pi over 6. Okay, so next A square will be R square plus 4R square minus 2 times 2, again 4R square, cos pi by 6. Cos pi by 6 will be square root 3 over 2. So this 2 will cancel out with this 4. So A square equal to 5R square minus 2 square root 3R square. That's what we can write it. Alright, so now if we square root both sides, rather before square rooting, we have to remove R. R has to be outside, right? So let's keep it like this. A square equal to R square, and we are left with 5 minus 2 square root 3 inside. And now we will square root both sides. A square root cancel out A. R square and R square root will also cancel out, so just R, but the remaining one will remain inside square root, which is 5 minus 2 square root 3, and this is what they asked us to show. Part B. Find the exact perimeter of the shaded region. So what is the shaded region? This is the shaded region, and we have our formula back. So we want perimeter, so that means this line is part of the perimeter, this line is part of the perimeter. This we just found out. R is already known to us. Only requirement is this arc. So let's add that. Perimeter equal to CA plus CB plus arc AB. So CA we know it. R CB we just found out. R square root 5 minus 2 square root 3. And arc length of a circle is r theta. So radius of this whole sector is 2r. So in place of r we will write actually 2r. And theta is the angle subtended by this arc on the center, which is pi by 6. So we can cancel this. So we can see that all three parts have r. So take r common. What are we left with? 1 plus square root 5 minus 2 square root 3, and here it will be pi over 3. That's the perimeter. Okay, let's go to the next one. Find the exact area of the shaded region. That is the C part. And let me do it here. Area of shaded region. So to find the area of the shaded region, we can find the area of this sector, the full sector, right? And remove the area of the triangle, this one. Remove it from the sector, and what are we left with? The shaded part. So this is what we're going to do. Let's find the area of the sector first. So area of the sector AOB minus area of the triangle COB. Okay, so area of the sector is, the formula is here, half r square theta. So which will be half, r is not r is 2r for this sector, r square, theta is pi by 6, minus area of the triangle is not there, not given to us, but we used it in first two questions. Let's write it again. Area of the triangle is half BC sine A. In some books or somewhere you can also see half AB sine C is the same thing. Only thing you have to take care that A should be the angle between B and C. Alright, so let's see what are B and C for us. So this is the angle known to us. So this will become B, this will become C. So B is R, C is 2R, and angle between them is pi by 6. Alright, so it will become half B C sine A. Alright, so let's open this bracket also. So half 4r square times pi by 6. This 2 will cancel with 4 and this 2 will cancel with 6, minus this 2 can cancel with this 2, so we are left with only r square, and sine pi by 6 is half. Okay, so we can write now area of the shaded part will be how much? We don't have 4 here, we have r square, common, so let's take r square here, and we are left with only pi over 3 minus half. That is the shaded area, and we have to find exact area again. So there's no need to convert it to any decimal. This is your answer. Here they have given a picture here, and this is a pulley. This circular thing is a pulley, and a cord is going over that pulley. Okay, it is not CHORD. CHORD is chord of a circle, but it is just CORD. It's a kind of rope, and it is stuck on a pin also. They're saying what is the length of the cord. Actually, they're asking what is the perimeter of this shape, this black, dark black color. So we know that this is part of this right angle triangle. Can you see? So we can find AP, and same will be BP. Why? Because the tangent to a circle from same point are always of equal length. So let me redraw this triangle again. So this is 90 degree, this is 5 centimeter, this is 13 centimeter. So what will be the length of this? So we can use Pythagorean theorem. So 5 square plus, let's call it x, equal to 13 square. So x square equal to 13 square minus 5 square. Square root both sides, x will be 12. So the length of AP is 12. Length of BP is also 12. The only thing left now is this circular part up to from A to B, which is actually the major sector. The angle subtended by major sector is this angle. So since we know that the arc length is r theta, so to find major arc we should have our formulas back. Here is this. So arc length is r theta. So we know r is 5 centimeter for this major arc. Only thing needed is theta. So let's find this angle, and then we double it to this, and then we subtract it from 2 pi, not 360, 2 pi, because this formula theta is in radians. So we have to find everything in radians. So let's focus on this same triangle again. So we know this is 5, which is this is the angle we are interested in. So this 5 centimeter will be the adjacent side, and we know hypotenuse as well. So adjacent hypotenuse is in cos. So let's write cos theta equal to 5 over 13. Theta equal to cos inverse 5 over 13, and that is 1.176. 1.176. Okay, so this angle is 1.176. This will also be 1.176. So our angle of the major arc, this theta, will be 2 pi minus 2 times 1.176. Let's keep it like this, okay? Or rather, maximum we can just multiply this one. So let me write it here. 2 pi minus 2.342, or the 352. Okay, so the arc length becomes r is 5, theta we just got 2 pi minus 2.352. Okay, so now we have to find the total perimeter, which is the length of the chord. Equal to 12 plus 12 plus this. Which comes out to be in 3 significant figures 43.7 centimeters.